Hey everyone, welcome back to another taste of physics. In this lesson we look again into the fascinating relationship between the electric potential and the electric field. These concepts are essential in understanding how charges interact, so it is worth a brief review. First, let's define what an electric field is. An electric field represented by the symbol E is a vector field that surrounds a charge. It shows the direction and strength of the force that a positive test charge would feel if placed in that field. In simple terms, it's how a charge creates a force field around that can push or pull other charges. When you move a positive test charge in an electric field, you are either working against or with the force of the field. This movement involves energy, which leads us to the concept of electric potential. Alright, now here's the key idea. Electric potential is all about how much energy it takes to move a charge within an electric field. Think of it like a gravitational potential energy when lifting an object against gravity. Similarly, when we move a charge against an electric field, we are storing energy as electric potential energy. Electric potential, symbolized as V, is a scalar quantity that represents the potential energy per unit charge at a certain point in space due to the electric field. The difference in potential between 2 points is known as the potential difference or voltage. Let's make the connection clearer. Imagine we have 2 points, A and B, in an electric field. The electric field tells us how much force would be exerted on a charge moving between these points, but the potential difference between A and B tells us how much energy is required to move the charge from A to B. Now, here's something to remember. The direction of the electric field is always from regions of high potential to lower potential. The field points in the direction a positive charge would naturally move. And remember, electric field lines are always perpendicular to lines of constant potential, also known as equipotential lines. So, how are electric field and potential mathematically related? Let's check the equation. The electric field E is the negative gradient of the electric potential V. What does this mean? Well, the electric field represents how quickly the potential changes over a distance. The negative sign shows us that the electric field points from high to low potential. Imagine electric potential like a hill, and the slope of that hill is the electric field. The steeper the slope, the stronger the electric field. If the hill is flat, meaning no change in potential, then the electric field is zero. Let's recap. 1. The electric field describes the force per unit charge in a region. 2. The electric potential is the energy per unit charge due to the electric field. And 3. The electric field points in the direction of decreasing potential and is proportional to how quickly the potential changes. And there you have it. The electric field shows us the force while the potential tells us about the energy landscape in that field. Together they give us a complete picture of how charges interact. I hope this video helped you clarify things. Thanks for watching and may science be with you.